And we should be all systems go. Okay, so thanks for joining me this evening. In this little webinar, we are thinking about complexity. Complexity is a word which crops up in the Key Stage 2 computing curriculum. And it's important to think about, what does complexity mean? Because it can mean different things to different people, can't it? And for the purposes of this evening, I'm going to be thinking about complexity as combinations of fairly simple things. And to some people, if you ask them what complexity is, they may well say that complexity is just lots and lots of instructions. So we might struggle to see the wood for the trees, for example. But as I say, from my point of view this evening, I'm going to be looking at complexity as simple things being combined. So this picture that I've got on the screen here, which I just found, it's got all the right licenses on it, don't worry, on Bing Images. And actually, if you look at it at first sight, it appears to be quite complex, doesn't it? But if you look a little bit closer at it, it's just lots of fairly simple lines and curves joined together. So it's just two ingredients, really, isn't it? It's straight lines and different types of curves joined together in a creative way to make something which appears to be quite complex. And this is what we can do with computer code as well. So the way that this works is really, in the previous webinars, we looked at how things like if blocks for selection work on their own, how repeat blocks and timers for repetition can work on their own, and we took a look at variables, how they can work. Now, I quite often think of those as being like fairly simple building blocks. And just like with building blocks, if you take a few simple blocks, you can put them together in lots of different ways. And it's like that with code. And that, to me, is where complexity lies, really. It's the many different combinations of those coding blocks we've looked at in the last three webinars that we can make something interesting with. So let's dive on in and take a look at something simple, relatively simple, to get going. This is a flowchart, a very simple flowchart. It says press play, which is how we want to get things going. And I want a little character to move right a little bit on the screen by controlling its X coordinate. Now, to do that, I'm going to just jump into given free code here. And to get set up, I need to go into design mode, and I'll drag an object onto the screen. I'll drag an animal onto the screen. Let's have this nice looking sheepdog here. Now, when we put an object onto the screen that we're going to use in our program, it has various properties. And if we look to the left here, we can see that this its type is an animal. Another property is its name, which is myAnimal1. I could change that just by clicking in here and changing it, but I'll leave it for time's sake. It's got an X coordinate though, an X value of 11. If I move the dog further along to the right, its X value is now 23. So I want to create a program which is going to move this dog across the screen by altering its X coordinate. So we can start off with the dog here at X equals 0. So I've got that. So I've got my design set up. I could give it a background if I want to. I will do, actually. Let's just make it look a bit nicer. So click the computer screen at the bottom, choose an image for the background in here, and let's just have the dog going across a nice field like this. Okay, so I can exit design mode. Now, my object, myAnimal1, is here, and I can drag this onto the screen, and I've got all of these properties which we've just seen are now accessible. So I can say to this, click on the X here, and I can say my dog, my animal's X coordinate, I want to set it to 10. No, I don't. I want it to just add, I want it to move along by one square or one grid unit. So I'm just going to say my animal, add 1. And if I press play, the dog has, believe it or not, moved along the screen a tiny bit because we can see here X equals 1. That's a very, very simple instruction, isn't it? I've changed a variable here, one of the built-in variables that the object, the dog, has, just by accessing it through the object here and saying add 1. Now, if I want it to, say, repeat every 3 seconds, then I'd have a different flowchart. So on here, I could perhaps drag my end down here, and I could put another instruction into the middle here and pop something in here like wait for 3 seconds. And then what I want to do is let's get some arrows on here. So we'll join these things together. So at the beginning, I want to press play, which will make the dog move right a little, and then it's going to wait for 3 seconds, and then we'll get it to move right again. Now this strange little mangled up line here is going to turn into a neat and organised thing like that. So we've now got this loop, haven't we? Move right a little, wait for 3 seconds, go back, move right a little, wait for 3 seconds. So we've got this loop here which is going to continue. I want that to be done with the timer. So to do this, I've got my variable changing block in here, but I need a timer. So let's grab a control block here of a timer. And when I drop this onto the code here, it's automatically choosing to be a timer which is going to wait for a second and then do something. So let's change that by clicking on the after to make it an every, and just increasing the 1 up to 3 seconds. So this timer will make whatever is tucked inside it or nested inside it. It'll make any instructions in here happen every 3 seconds. So let's drag my animal command into there. So now reading this through, we've got a bit of complexity. We've got a combination of a timer making something happen every 3 seconds, and we've also got the variable, the property of the animal changing. So if I press play, we should see the dog take a little jump along every 3 seconds. There he goes. Another 3 seconds. And at the bottom, you can see here in the variable watch window, we've got this useful tool where we can watch the X coordinate increasing every time we change it with our line of programming here. So a very sort of simple introduction to complexity there, in that one thing is being controlled by another, isn't it? So our command here to add one is being controlled or triggered by the timer. So we've got that sort of special relationship between them. Now, another thing that we can do, let's choose another example here. I still teach myself, and some of the children were complaining after coming back after the COVID break that they had to come into school again, and that they only had 2 days at home, and we were talking a bit about repetition then. And we got this flowchart here, which really says, you go to school, and then have you been 5 times? Well, if you haven't, then you need to go to school again the next day. So this is sort of a morning check. So on morning 1, it's going to say, go to school. And then you go to school. Have you been to school 5 times? If you have, then the next morning you stay at home. Have you done that twice? Well, not yet. So the next morning you stay at home. Have you done that twice? Well, yes. And now I need to go to school again. So what we've got here is a sort of alarm clock instruction that will tell us 5 times in a row to go to school, and then twice in a row to stay at home for the weekend. And we could repeat that over and over as the weeks of a half term progress. So let's take a look at how that looks in code. Now, I've got a couple of instructions set up here. I've got this little thing which is going to, when I press play, it's just going to print up on the screen either go to school or stay at home. So we need to get that to say it 5 times go to school, then twice stay at home if it was going to sort of repeat correctly. So what we can do here is drag a repeat block in, and let's pop that in here. So we're going to say repeat 5 times, and then let's pop our print screen go to school here. So it's going to do that. And then we need another repeat. So we've got 2 repeats here, which is again a little bit of complexity, isn't it? We're having to, it's not a simple thing that says go to school every day. It's saying go to school 5 times, but then repeating stay at home twice. So if I press play now, hopefully we can predict what that'll do. And yep, go to school 5 times, stay at home twice. Now, here's where it can get a little bit more complex, because how many that's 1 week effectively, isn't it? 5 days of school, 2 days of weekend. So we have 1 week there. How many weeks are there in a half term? Well, in the local authority I teach in, we've got 7 weeks in the next half term. So here's what I need to do. Can you guess? I'm going to pull a repeat block out. I'm going to say repeat 7 times. And then I'm just going to have to pull all of these instructions inside it. So what you can see here is definitely increasing in complexity, isn't it? We've still got the simple basic building blocks of repeats and printing information on the screen, but we've got this sort of quite complex arrangement of them to build our alarm clock system, which is just going to say 7 times, go to school 5 times, and then stay at home twice. And it's worked. That's great. It's done exactly what I wanted it to do. So we could get it even more complex by saying at the end of the week, well done, you finished week 1, and then it could count up and say, congratulations, you finished week 2 the next week, and so on. Which actually possibly isn't a bad thing to do as we're talking about building complexity. It could be quite a nice thing for a child to say that. They could perhaps come up with a program like this and then say, oh, I want to adapt it, I want to improve it. So, but before I do that, let's just be aware of what's gone on here, because we've got this thing again called nesting here, haven't we? We've got 1 level of indent, we've got 2 levels of indents to go to the print screen here. And every time something's indented or tucked underneath something else and joined onto it, it means it's triggered by or controlled by that block. So everything inside this repeat 7 times is going to happen 7 times. Everything inside this repeat 5 times is going to happen 5 times. Let's add that variable and see if we can get it to say, congratulations, you finished week whatever as we go through. So to do this, I'd need to create the variable at the very beginning. What type of variable is it? Well, from the previous webinars we've looked at, we've got numbers or strings. Now this is going to be a number, and it's going to be called, I'm going to call it week number. And initially I'm going to say that week number is 1. That's what I want that variable number to start off as. And to print it out, all I'm going to do is at the end of my week, I'm going to drag a print to screen box in here which says, let's put an instruction here. So let's say congratulations dash you survived week. And then, now when I've done that, I'm going to click a plus at the end here. Because what I want to do is to add something else on. So I'm saying print to screen this text in here, and then on the end I click into the box and I want week number. So if I press play now, what happens? Well, I'm not seeing the week numbers, and then right at the end it's saying congratulations, you survived week 1. If I can just drag that variable watch box out of the way, there we go. So it never ran it because it wasn't part of the repeat 7 times loop. So if I drag it in here, lots of children would do that. And now we're getting tangled up a little bit in the complexity, which is giving us a great opportunity for some debugging, isn't it? So in here, I've got to think, right, what has actually happened here? I suppose the first thing that's happened is every time it says stay at home, it afterwards says, congratulations, you survived week 1. Here we go. Stay at home, congratulations, blah, blah. Stay at home, congratulations, blah, blah. But it doesn't say it after go to school. So where should this print to screen block be? Because it's in the wrong place. So I've got a bit muddled by my complexity, haven't I? So if I drag it across to here, it needs to go here so that it happens at the end of every week. So just looking at the output now, because as soon as I made a change, it ran the code again because I've not pressed stop up there. But let's just go back to the top and see exactly what happened in here. I can't because I'm still running it. So in here, it's saying go to school 5 times, stay at home twice, and then putting the congratulations. So we're doing pretty well, only it's not changing the week number. So I need to add something else to change that week number, don't I? Go down there, variable watch. There we go. So again, create variable, no, but change variable. And again, I need to put this in the right place. So let's just click on week number. And I don't want to set it to something in particular. I want to increment it or add 1 onto it. So I'm just going to say week number plus or add 1 to it. And because I've put it straight after the print screen box here, it's going to print the week number and then immediately add 1 onto it, ready for next time. So if I press play now, hopefully we should have that done. And there we go. So you can see that in this case, we've got a fair bit of coding block there. Certainly structured, isn't it? We've got lots of indents giving it that sort of nesting and things controlling other things like we have there. And we've got a variable thrown in there as well for good measure. Great. So, and it's told me which weeks I've survived as well, which is fantastic. Great. Now, other things that we can do are you can have nested timers. So, for example, the chimp activity of magician uses this. The first thing that we have to do here is to make the rabbit disappear. It says use a timer to hide the rabbit after 5 seconds. So again, for very young children, we can just have this sort of timer waiting 5 seconds, and then rabbit we drag on here, and the properties are to hide. So let's tick that and press play. After 5 seconds, the rabbit should disappear. There we go, it's gone, magic. And on next challenges, the rabbit reappears after another 5 seconds. So these activities here guide children through it. They also guide teachers through it, which is quite a nice thing. Now, the interesting thing about this is lots of children will put it just here. So we've got to make the rabbit disappear for 5 seconds, which we've done, and we've got to make the rabbit reappear after 5 seconds. So we'll say rabbit show. Lots of children will do this, and they'll press play, and the rabbit will... Oh, did you notice they both flashed orange at the same time? That's because what happens here is the program, when it runs, everything on this sort of outer level of indentation happens one after the other. So the first thing that happens is it sets up a timer for 5 seconds, which is then going to hide the rabbit. And immediately after the computer's done that, it's going to set up a timer again for after 5 seconds to make the rabbit show. So there's no delay. What we have to do here is to drag this timer inside the other timer. What this makes happen is, let's just read it through in sort of plain English. First timer waits 5 seconds and then hides the rabbit. Now here's the important bit. It hides the rabbit, and because this timer is on the same level of indentation, we need an and. So going back to the beginning, this timer waits 5 seconds, it hides the rabbit, and it starts another timer which waits 5 seconds and then shows the rabbit. So again, a little bit of complexity here, haven't we? It's not as straightforward as it appears, because we have to get that logical idea of how the program is working. So, even on very straightforward seeming activities, you can get this bit of complexity. And on these activities, you've got videos here and hint videos to give you a little bit of help with that if you want to. The last one that I'm going to show you this evening is one which uses selection. And this is similar to the X coordinate that I was using with the dog earlier. And this comes from the Gibbons section. Make the knight move right. So let's just click into this. I don't need the video because it begins really easily. We just have to drag this knight on here and say go right and press play. So far so good. Here's where it gets quite complicated because the knight's nipped off and we need to get him back. And I'm using the wrong version of this one actually, so let me just exit that. I want to come into Guard the Castle 2, not Guard the Castle 1. Just bear with me a moment, I apologise for that. This is the last one that I'm going to show you from here, so we should be finishing within another couple of minutes. I'm just giving you a flavour of what complexity is this evening. Like I said at the beginning, complexity comes when we put together ifs and repeats and things. And I hope you're getting a flavour already that you can combine them in many, many different ways. So there are some key principles really to be to be mindful of when we're doing this. And I'd say the most important one is this idea of indents, and indents are controlled by what they're tucked in underneath. Now, here's this knight. He's gone off home early. He should have really turned around and guarded the castle. So our next challenge gets more complex. It's saying here, make the knight change direction when it goes too far to the right. So what we've got to do here is, the challenge is helpfully telling us to make a timer as the first bit here. So let's drag a timer in, and it's saying that checks the knight's X position every second. So we don't want it to be after 1 second. We need it to be every 1 second. As I do this, notice the level of detail and attention to detail I'm having to pay to this sentence here. It's almost like a reading, you need good reading comprehension and attention to detail to solve these more complex problems. Children I work with often complain that coding's hard, Mr. Heath. We thought it was going to be easy because we're used to playing games on our iPads and computers all the time, and it should be leisurely. Well, no, this is school and we're doing a subject now, and you've got to think. Anyway, so this is going to make whatever's in this box happen every second. So we need to say this check. So every second we need to check if something to do with the knight, let's click that. So if the knight's X equals, let's type 15 in there. So I'm almost there, aren't I? What's the check I've got to do? If the knight's X coordinate is greater than 15, and I've got equals here, so again, attention to detail, greater than 15, then make the knight go left. So let's pull that in here. And just as we've seen in other webinars on selection, we've got this nesting here. The knight will only go left when the knight's X is greater than 15. That's the control, the control that we've got over this. And that check is also being controlled by the timer every second. So timer controls if check controls knight's movement. We're getting complexity here, aren't we? Let's play it and see if he does indeed turn around. I hope he will. So he gets to X equals 15 and he turns around. Now the next challenge on here says that he's got to turn around the other way. He can't walk off the other edge of the screen. And children, when I teach them this, will very, very often do something like this. So when the knight's X position is less than 5, so that's quite easy to put in, isn't it? If the knight's X position is less than 5, then make the knight go right. Okay, can you predict what's going to go wrong with this now? So take a look at this code. We start off by the knight going right, and then everything in this timer box happens every second. So every second we check if the knight's X position is greater than 15, then the knight will go left. And then as soon as that timer is started, we're going to check if the knight's X position is less than 5. And if it is, we'll make the knight go right. Let's press play. Pay close attention to anything flashing orange on this right-hand side when I press play. Did you see it? How this one here flashed at the bottom, this if check, but it's never being checked again, is it? Can you see why? So this is debugging skills now as part of complexity. It's not flashing every second because it's not inside this timer block, is it? So again, we need to get that in here. Children will pull it in here, and then it only does the check if the knight's X is greater than 15. Hopefully you saw that. Let's watch that again. So because it's tucked in here and controlled by knight X greater than 15, it only does the check for less than 5 once, about now, and never checks it again. So it got the wrong indentation. And again, this is complexity causing difficulties. Let's just pop it out to drag it out one level. So I need to carefully get that orange line in the right place, and now it should work. So they're both flashing every second, and that should keep the knight on the job. There he goes back again. So, folks, thank you for watching this. I mean, as I said at the beginning, I can only give you a taster of complexity because by its nature, there's so many combinations of possibilities. Just like in this design here, the number of combinations and possibilities for curly lines and straight lines being put together, it's immense. And through complexity, we can give children a really great opportunity to be creative. Thanks for watching. Goodbye.